I'm Anil Kumar. Welcome to my series on lines. Now in section 1.2, we'll learn about slope and gradient. They're kind of same things. We'll actually begin with basic concepts, taking some examples. Then we'll have review questions. And then we'll have a bonus question. The next video will be on application of the slopes which you have learned here. So I'll also share with you 4 application questions which you can try after learning all these concepts. Let's first share with you the review questions and the bonus question so that when I am explaining you the basic concept, you should understand what we are targeting for. Perfect? Okay, so here are first 4 questions. We are saying that slope of a line through these 2 points is 2. Find the value of P. So you'll notice 3P we are given. We need to find the value of P. Question number 2. Find the slope of line passing through these 2 points. That's a straightforward question. Question number 3 is find the slope of a line passing through XY where X plus Y equals to 10. So that's kind of tricky. Question number 4 is vertices of a triangle are 0, 3, 4, 5, 6, minus 2. Which side of the triangle has the maximum gradient or maximum slope? Next 4 questions for you are slope of a line passing through origin is 0.75. Which of the following points can be on this line? Question number 6, slope of a line passing through points A, B and A plus 3, 3B is 6. Find possible value of B. Question number 7. Product of slope of 2 perpendicular lines is minus 1, right? If slope of a line is half, then find possible slope of a line perpendicular to it. Question number 8. 12-meter ladder is leaning up against a wall of a building so that it reaches 8 meters up the wall. What is the slope of the ladder nearest to 10th place? Now here are application questions. Question number 9 here is a ramp is formed touching the corners of 2 square blocks placed side by side. If area of these square blocks is 9 and 64 respectively, find the gradient of the ramp. So units could be, we could use a meter square, okay. No problem. Any unit, but unit square. Okay. Question number 10 is maximum gradient for a ladder to be stable is 7 at a working site. If a 20 feet ladder is placed against the wall, then almost how high can the ladder reach? Then we have a bonus question which we'll also solve in this particular video. Question number 11. Find the 4th vertex of the parallelogram if coordinates of 3 points are 2, 3, minus 1, 5 and minus 3, 0. So these are the questions which we will be working with in this particular video. And once we are done with this, you should be in a position to answer some application questions. Let me share that with you. This is going to be the next video. So we'll actually have these 4 application questions where question number 1 is find the value of P if the points 1, minus 1, 3, 3 and minus 1 P are collinear. Question number 2. Are these points vertices of a right triangle? Question number 3. Point 34 is on a circle with center at origin. Find y-intercept of the line tangent to the circle at this point. Question number 4. The points A, B and C are vertices of a rectangle ABCD. Find the coordinates of the point D, right? So these will be your application questions which we'll solve in the next video. But I hope you will learn good enough concepts to answer these questions right now after the video. So let's begin with the basic understanding of what slope and gradient is. So now let's talk about slope of a line. To begin with, let's get back to our coordinate plane. Let's say that is the y-axis and this is the x-axis. To understand slope, it is always a good idea to take few points on the coordinate plane and algebraically work out the slope itself. So let's say I have a point here, and let us say the coordinates of this point is, let me call this point as A, and we'll write the coordinates as 2, 3. Let's say 2, 3, okay. Now let me take another point here, which is, let's say B, and the coordinates for point B, let's write them as, let's say 4 and 8. Okay. So these are the coordinates of our 2 points A and B. When we say slope, what does it mean? Look here. When I join these 2 points with a straight line, I get a line segment which is kind of rising. Do you see that? So slope basically means the rate of rise of a line, right? So basically what we're trying to say here is that how fast does it rise as we move along the x-axis. So if I am moving on the right, we see that every point on this line actually rises, and the steepness with which it is going up is kind of constant, right? So even if I take a point here on the line, it has the same kind of slope. You can see that, right? So on a line, every point, any 2 points will have the same slope, correct? So how do we find this? Algebraically, we actually calculate slope by the change in height or rise, which we say delta y, that is the change in height or the rise, and delta x as change along the horizontal x-axis. So we actually define slope as rise over run, and algebraically it is change in y value over change in x value. Change really means y2 minus y1 over x2 minus x1 if x1 y1 is one coordinate and x2 y2 is the other coordinate. We also represent slope with letter m. So in general, we'll be representing slope with letter m. So to calculate slope between A to B, we can write m from A to B is equal to what? So y2 minus y1 means difference of their y values, 8 minus 3. So 8 minus 3 comes on the numerator side, 4 minus 2 comes in the denominator. See, the order has to be maintained. If you take this as the second point, then be these values, take away those values, y values come on the top, and the differences in the x values is the denominator. So take a precaution, don't flip it, not changing the order of operation. Is that okay? So 8 minus 3 is 5 and 4 minus 2 is 2. So we get a slope of 5 over 2. That really means that if I move 2 units to the right, then I move 5 units up, right? So do you see it makes sense? If I add 2 to 2, then where do I reach? I reach this point, which is 4, 3, correct? Now, from here, if I add 5, I reach here, right? 3 plus 5 is 8. Do you see how we reach that point 4, 8? That's another way of saying it. Well, you will also appreciate that on this line, if I extend this line, right? So if I have some other point where, let us say now, we have the x value as, let us say 5. Then we need to find what should be the y value. Right, so that's a kind of question for you. What will be the y value, right? So in this case, well, the x value is 5, but the y value here, because this is a horizontal line, will remain as 3. Not a problem. But what happens to this point C? So the point C, the x value is 5. What should be the y value? Now that could be a very tricky question most of the time. But what you see here is that we are talking about two similar triangles. So whenever you're looking into similar triangles, you will also note here that the ratio of sides is kind of same. So if I write this value to be, let us say we write this value as lowercase c. Okay, in that case, what we notice here is that this height, change in height, now we say delta y dash over delta x dash, that should be same as delta y over delta x, right? The change should be same. So what is the change now? Let us find the slope again. So the new slope between a to c is what? We don't know what this value c is. We'll do c minus 3 divided by 5 minus 2. Okay, but we know what slope is. Slope is same, which is 5 over 2. Does make sense to you? So that helps to find a new point with the same slope. You get the concept, correct? So from here we can say c minus 3 over 3 is equal to 5 over 2. So we can cross multiply and we say c minus 3 is equals to 3 times 5 over 2, which is 15 over 2, correct? Yes. So what is c equals to? Well, now we can find that c should be equal to 15 over 2 plus 3, which is how much? Well, 3 times 2 is 6. 6 plus 15 is 21 over 2. Does make sense to you? So this point c, we found that should be 5 and the y value is 21 over 2. Kind of complicated to begin with. But that's where we are heading. So the whole idea of now looking into slopes is not just learning the basic concepts, but actually while learning to keep in mind how interesting questions based on the concept can be solved. Perfect. So that is an excellent example. Correct. As an exercise, you could try and find a point which will be intersecting the y-axis. So this is our x-axis, this is the y-axis. So I'd like you to find this particular point. Let's call this as 0 lowercase b. Of course, the x value will be 0, correct? On the same line. So that is your bonus question. Perfect. Okay. Now let's get back to some more concepts about the slope. Few interesting things. If I have a horizontal line, well, a horizontal line will have what slope? What is the rise here? Well, since the rise is 0, it has a 0 slope. It has 0 slope. Why? Because the rise equals to 0. So 0 divided by anything is going to be 0, and therefore the slope will be 0. Okay, then what is the slope of a vertical line? Now, vertical line, for example, the y-axis. If I take 2 points here, let's say the other point is 0, 5. And let's say one point is 0, 0. Then what is the slope between the point E and O? Well, the slope between E and O should be 5 minus 0 divided by 0 minus 0. That means 5 over 0. Well, that is undefined, right? This is undefined. Why? You cannot divide by 0. That is undefined. So, the slope between these 2 points, 0, the origin, and E, which is a part of your vertical line, is undefined. You get the idea, correct? So, these are the questions which we should be looking into. Well, let's take another line here which has a negative slope. So, I'm actually considering 2 points here, P and Q, for example. And if I know that the coordinates of point P are, let's say, minus 5 and 6, and if I know that the slope is half, let's say we know that the slope of PQ is basically negative half since it is going down. And if I want you to write down the coordinates of Q, let the coordinates of Q be, let us say we this time write the x value is not known, but let us say that the y value is 5. Then can you tell me what could be q? Well, this could be another very interesting question, right? Since we know that the slope is negative half, and we also know the kind of formula right there, we can say y2 minus y1, that is 5 minus 6 over q minus 5, that means q plus 5, should be equal to minus half. Now that equation should help us solve for q, right? So if I cross multiply, right? If I cross multiply, so I get minus q minus 5 equals to what? 2 times minus 1 is minus 2, right? And so taking q on this side, minus 2 on the left side, we get minus 5 plus 2 equals to q, and that gives me a value of minus 3. So in this case, q has to be minus 3. So we found that the point q is basically equal to minus 3, 5. Did you see that? So in this particular page, it is not just a beginner's slope gradient concept. It is a lot more, right? So I'd like you to go through this once again. So what we have learned here is that if a line is rising, we always see from left to right, then we have a positive slope. If the line is falling, we have a negative slope. Horizontal line, zero slope. Vertical line, undefined slope. If we know slope and a point, we can find the other point. We can also find points on the same line by comparing the ratios, right? It's like similar triangles. So I hope with this you got fairly good idea about what the slope is, and we also use the word gradient, means the gradient is how much, means slope is how much. And at times we'll also use the word rate, rather rate of change. Since it gives you change in y value, which is independent variable, to the change in x value, which is a dependent variable. So it gives you rate of change in many applications. That will be our next unit, right? But at present, you could always relate slope with gradients and rates, and I hope the definition is absolutely clear. It is rate of change of position in a coordinate plane. As you can see here, it is rise over run. It is difference of y values divided by difference of x values, and so many ways to define it. Now, let's take some review questions. So I hope you got all the concepts. Now, let's review with the help of examples. Here are set of first 4 questions for you. You can pause the video, answer these questions, and then look into my suggestions, right? Question number 1. Slope of line through A, 3p, and B, 7 minus 2, is 2. Find value of P. For slope, we are going to use this formula, m equals to y2 minus y1 over x2 minus x1, right? Change in y values is always on the top, divided by change in x values, right? So do not interchange it. Okay. Let's see how to answer. So we are saying that the slope is 2. So let me do the solution here. So we are saying slope between points A and B, so is 2. So this value is given to us as 2. But how do we find slope? y2 minus y1, so we get minus 2 minus p divided by 7 minus 3. 7 minus 3. Okay, 7 minus 3 is 4, so I could multiply 2 with 4. And in the numerator, I have this minus 2 minus p. And that is 8 for us, correct? We need to find the value of p. So let me take this p on the left side and 8 on the right side. So we get minus 2 minus 8, which is definitely equal to minus 10. So we get option A as the right option. Is that clear to you, right? So that's how we're going to answer the very first question. Question number 2. Find the slope of a line passing through point 2, 3 and minus 3, 3. Okay, how do we solve this? Well, you can again use the same formula and then figure it out. The other way here is to look at the points carefully. These are multiple choice questions with that at times you have to do in minimum time within a second. So if you see that the y values are not changing, that really means what? That really means that we have the 2 points which are horizontally placed, right? One of them is minus 3, 3, which is on the left, of course. The other one is on the right, which is 2, 3. Now, what is the rise here? Rise is 0. Since the rise is 0, 3 minus 3 is 0, right? So we expect 0 as the slope. It is a horizontal line. Do you see that? So for a horizontal line, the slope is 0. If we have a vertical line, then it is undefined. Now let's look into question number 3. Find the slope of a line passing through xy where x plus y equals to 10. How do we do this one? Now, we have to somehow get change in y over change in x. So what do I suggest? Well, so what we will do here is that to find slope, we need 2 points. We need 2 points. So what I do here in this case, I have an equation kind of thing, x plus y equals to 10. Okay, so let us say if x is 0, then what is y? So if x is 0, then y is 10, correct? Yes, of course. And if y is 0, well, then it is 10 and 0. 10 plus 0 is 10, 0 plus 10 is 10. So we get 2 points. You get an idea. So this is a thinking question. Once you get 2 points, then it is kind of easy. Okay, how? Do y2 minus y1. So you do 0 minus 10 divided by, so we are doing 0 minus 10 divided by 10 minus 0. Okay, so we get minus 10 over 10, which is minus 1. So the right answer is D here. Does it make sense to you? So the questions are very interesting and they will help you in many exams and tests. That's the whole idea. Question number 4 here is, vertices of a triangle are given to you. Which side of the triangle has the maximum gradient? Gradient means slope, right? Okay. So basically we need to find slope of all the 3 points, okay, between 3 points. The other thing which you could do here is kind of sketch. So we have 0, 3. So 0, 3 will means a point is, let's say here, 0, 3, okay, since those are big values. 4 and 5. So this is 0, 3. Then we say 4 and 5, let's say here. And then we are saying 6 and minus 2. 6 and minus 2 is here. So if you look at this triangle, right, you see this is very steep, right? So what you notice here is that this section, this is your A, this is B, and this is C. Now this is very steep, right? And therefore, the answer is BC. Now it is important to note that when we are saying maximum gradient, then we are talking about absolute value, right? Don't think that this is negative slope. Yes, it is negative, right? Very steep, but negative. Even then, this will be treated as the side with maximum gradient, okay? So B to C will be your answer. What you should do here is also verify by finding slope, right? So you can find slope between A to B. You can find slope between B to C. You can find slope between C to A, compare. But if you kind of think about it and graph it, as we just did it, right, then you can answer this multiple choice question within seconds. So that could be our approach. So as you can see here, many times the approach could be to visualize and then answer slope-based questions. I hope that makes sense. Now let's take the next 4 set of questions. Question number 5 is, slope of a line passing through origin is 0.75. Which of the following points can be on this line? So think about it like this. We have a line. 0.75 means what? Well, 0.75 is like 75 over 100, right? Or 3 over 4. So that means there is a rise of 3. Rise of 3. So like 1, 2, 3. And run of 4. 1, 2, 3, 4. And it's going through origin, right? So it's kind of like this. You could go this way also. You see. So we get 3 over 4. That means we actually ran 4 and went up 3. So it could be 4, 3 as one of your answers. But if it is not on this side, you could run on the other side also. Does it make sense to you? And reach here, which could be what? Minus 4, minus 3. So these could be your points since we are given combinations of 3 fours. So minus 4, minus 3 is my option D, which is the correct option. Does it make sense to you? So as I was saying, many multiple choice questions. You should think graphically and then answer. Question number 6. Slope of a line passing through point AB and A plus 3B is 6. Find possible values of B. Well, that is clear algebra, right? So slope here, let's calculate. So we will try to calculate here slope M equals to what? Change in this value, which is 3B minus B divided by change in A values, A plus 3 minus A. That gives you 2B over, this is 3, and this slope is given to us as 6. So now we can cross multiply and write 2B equals to 6 times 3, which is 18. And dividing by 2, we get B equals to 9. So option C is the right option. Perfect. Now these are the type of questions which you should be ready for once you do my videos, okay? Now question number 7. Product of slope of two perpendicular lines is -1. If slope of a line is half, then find slope of the line perpendicular to it. Now this is a concept, right, which we'll explore further later. So it says product of perpendicular lines. So if one slope is M, the line perpendicular will be, when you multiply these two, you get -1. So what we are saying here is that M times slope of perpendicular line is -1. This is what we are saying here. Product of slope of two perpendicular lines. So one is M, the other perpendicular line will be -1. If slope of a line is half, then find slope of the line perpendicular to it. So we are saying one of the slope is half, you find slope of the perpendicular line when you know their product is -1. So well, from this equation, perpendicular lines should be having a slope of -2. Just cross multiply. So we get option D as the right option. Perfect. So that is how we are going to solve it. Now, question number 8. And after question number 8, we'll take a short break and then move on to our application questions, which will be kind of open questions, not multiple choice. A 12-meter ladder is leaning up against a wall of a building so that it reaches 8 meters up the wall. What is the slope of the ladder nearest to 10th place? Now this is one of those questions where the calculator will be allowed. So till now, all the questions which we did were without calculator, correct? So let me just on the side draw this ladder, and then we'll try to see how to solve such a question. So we have a ladder here. Let's say this is the ladder. Okay. Now it says 12-meter ladder, means this length is 12 meters, is leaning up against a wall of a building so that it reaches 8 meters up the wall, right? So this distance is 8 meters up the wall. What is the slope of the ladder nearest to the 10th place? Oh, how do we find it? So that means we should find this distance. Then the ratio 8 over that will give us the slope, right? Okay, how do we find this distance? Well, that is application of Pythagorean theorem. So this is kind of a very interesting question. So how do we find this distance? Let's call this distance as x. How do we find this x distance? Well, we know that x square plus 8 square should be equal to 12 square. Perfect. That is to say that x square plus 64 equals to 144, and that is x square equals to 144 minus 64. Correct? Now we need calculator to find square roots. We are not so good at it, so we'll just say, well, we'll do that much, 80 square root. So the value of x basically is square root of 80. Right? Now one decimal place, so we'll use calculator and do square root of 80, and it gives you in decimals answer as equal to 8.94. It gives you 8.94. So we get this x value is 8.94. So what is the slope now? So the slope here, which is m, is 8 divided by 8.94. Correct? So let's calculate this answer. So how much do we get? 8 divided by 8.94 equals to, in decimals, is 0.894. So we get this as 0.894. Okay, so which rounds to how much? 0.894 rounds to C, which is 0.9. So the slope of this ladder is 0.9. Does it make sense to you? Perfect. I'd like you to go through these solutions once again. We'll take a short break, and after the break, we'll actually solve our application questions one by one. Thank you. I hope you enjoyed the break. The wildlife here is pretty good, even in the heart of the city. Now that gives you a fresh mind to work, and here are application questions. So let's begin with question number 9. A ramp is formed touching the corners of two square blocks placed side by side. If the area of these square blocks is 9 and 64 meters square each, respectively, find the gradient of the ramp. So let's try to understand the question first. Let's say this is the ground. We'll assume this to be a level ground on which we have two square blocks. Let's make two square blocks. One square block and then the other one. So it's that the other one is bigger, okay. Two square blocks. We are given that these square blocks have area of 9 and 64. So that is the area. And what we are trying to figure out is that there is a ramp which is touching these corners, right? So ramp is kind of going like this. We need to find the slope of this. That is the question, okay? Now I hope the situation is absolutely clear. Let's see how to find this particular slope. As we know, slope basically is rise over run. Now, when I say that the square block means all equal sides, 64 area, that means each side is how much? Each side is 8 units, correct? Since we wrote meter square, we'll consider that to be 8 meters. For the second one, 9 means what? 3 units, correct? So 3 is the length of each side. Okay. So that really means that the rise is how much? The rise basically is 8 minus 3. So in this case, we get rise as 8 minus 3, right? That difference, 8 minus 3, right? And the run is how much? Well, this width we know is just 3, right? Because each side is 3 for this particular square is 3. So we get rise over run as 8 minus 3 is 5 divided by 3. So 5 over 3 is rise over run. So the slope is equal to 5 over 3. Is that clear to you? So that is how we are going to solve this question. I hope that makes sense. Now let's take another application question based on slope. Question number 10 here is, maximum gradient for a ladder to be stable is 7 at a working site. If 20 feet ladder is placed against the wall, then almost how high can the ladder reach? Okay, you can actually pause the video and answer this particular question. Now this question is similar to one of the examples which we have done earlier. Correct? So here's the scenario. We are this time given that the ladder, the maximum gradient of the ladder, we are given the slope. When we say gradient, we are given the slope. Maximum gradient of a ladder to be stable is 7. So 7 is our slope. If 20 feet ladder is placed against the wall, that means this is 20 feet, the length of the ladder, then almost how high can the ladder reach? So we need to find this height. Well, in this particular case, there are two unknowns. We even don't know how far is the base from the wall. Let's call this as B. Okay, we even don't know this. We know the ratio is 7. That is to say that we know that height divided by base, this ratio is 7. Since the maximum slope is 7, right? So that is the maximum slope. So that will give us the maximum height. Is that clear? So that is known to us. Now, there are two unknowns. To solve for two unknowns, we need two equations. How do I get the second equation? Well, to get the second equation, I have to see like this is a vertical wall. So we have to assume that this has to be a vertical wall, right? So if this is a vertical wall, we can use Pythagorean theorem. Which is that sum of squares of h and b should be equal to 20 square. So that should help us to answer the question, correct? Now we need to find maximum height. So we can say, well, in that case, we can say that, how to find, we have to write one of these variables in terms of the other one. So we say now height divided by 7 is basically base. Correct? We can say that. Okay. So you could do that, or if you want to avoid the fractions, then you can write height is 7 times b. So I'll prefer this, and then we'll get back to height. Okay, fine. So we'll use height as 7 times base and replace height with 7b in this particular equation. So we get 7b square plus b square equals to 20 square, which is 400. 7 square is 49, so we get 49b square plus b square is 400. Well, 49 plus 1 is 50, so we get 50b squared as 400. So that means b squared should be 400 divided by 50. Well, 1 cancels, and that gives me 8. So b should be square root of 8, which is 2 square root 2. So we get the value of b. Right? So since we know the value of b, we can find what height is. So we know height is 7 times b, right? 7 times b. This is what we had. So we'll multiply this by 7. So 7 times 2 square root 2. So that gives me 14 square root 2 as the height. Perfect. And since we're talking about feet, so the height answer will be how much? 14 square root 2 feet is the exact answer. Correct? So approximately, if you want to do it in decimals, you could do 14 times square root 2, which in decimals is equal to 19 point, you can say approximately 8 feet. Is that clear? So almost 20, right? 0.2 feet less. So that is how we are going to answer this particular question. I hope that makes sense, right? So I'd like you to go through this solution once again, try to understand how we use Pythagorean theorem to solve this question. Now the last question here is our bonus question, question number 11. Find the fourth vertex of a parallelogram if coordinates of 3 points are 2, 3, minus 1, 5 and minus 3, 0. I'd like you to pause the video, answer this question and then look into my suggestions. Let's try to plot these points and then we'll figure out the solution, okay? Using a graph, as I said, is always better to solve such questions based on slope. We are given here a parallelogram has 4 points, of course, and 3 points are 2, 3. So let's say this is 1, this is 2, and this is 1, 2, 3. So this is one of the points. So let's call it 2, 3. Okay. Minus 1, 5, that means minus 1, and 3 is here, 4, 5. Let's say this point is minus 1, 5. Then we have minus 3, 0, that means 2 and 1 here. So this point here is minus 3, 0. So these are the 3 points given to us. We have to form a parallelogram and get the fourth point. Correct? So let's say this is how we are joining them. Okay. Now to make a parallelogram, how I'll have some point here. Is it okay? So that somewhere here, right? And this will go down. That should give me a point. Perfect. Let us see how to find this point. So let's understand the concept. These two sides are parallel. Parallel sides means they have the same slope. So let's write down. Parallel side implies same slope. Same slope means same rise over run, correct? Now, if you compare these 2 points, we are given these 2 points, right? Minus 1, 5 and minus 3, 5. That means what? Well, 5 means you're going down. So here delta y is basically equal to change in 5 to 0, which is 5. And delta x, change in x value, is from minus 1 to minus 3. So that is actually equal to how much? So when you do 0 minus 5, actually I should have written minus 5, take away 5, you get this. Now here you should take away 2, right? To get to minus 3. So that is the change. So what we are going to do here is from here getting to this point, we'll take away minus 2 from the x value and minus 5 from the y value. So if you do that math, what do you get? Well, 2 minus 2 is 0 and 3 minus 5 is minus 2. Correct? So we get a point which is 0 minus 2. So that should form the fourth point. Does it make sense to you? Correct. So we are saying that the fourth point is 0 minus 2. Let's check. So that is an excellent way of doing it. Let's check. So when we say that this is the fourth point, we have to ensure that these two lines are parallel. So let me label them, right? So now let me label them A, B, C, D, okay? We'll just say A, B, C and D. Now what is the slope from B to A? Slope from B to A is basically 3 minus 5 divided by 2 minus minus 1, which becomes plus 1. So we get minus 2 over 3. That is the slope. Now let us also find the slope between C to D. That is minus 2 minus 0 divided by 0 minus minus 3, right? Which is also minus 2 over 3. Now since these slopes are same, we got this, right? So slopes BA is equal to slope of CD. That means what? That means parallel. So we have shown that this point is correct. And therefore we get our answer that D, the fourth point, should be 0 minus 2. Is that clear to you? So without doing much calculations, just with the concept of slope, we could answer this beautiful question. Now this concept will be applied to find the fourth point in a kite, in a square, in a rectangle, even in a triangle, in many different ways. So those are going to be huge applications. So I hope overall you learned quite a bit in this short period of time about slopes. And you also saw how to do some very difficult questions based on this concept. Now, we have just 4 more examples for you. I'd like you to pause the video, copy these 4 examples, try them out, and then in the next video, I'm going to share with you the solutions of all these 4 questions. I'll provide you with a link of the solutions in this video so that you could explore and check your solutions. I hope you find it useful and interesting. The whole idea of this series is to provide you with just the right kind of information you need in the minimum time. I hope we are close to that. Share your views, share my videos with your friends, and if you like and subscribe to them, that'd be great. Thanks for watching and all the best.